Hello friends, this video on dual nature of radiation and matter part 6 is brought to you by examfear.com. No more fear from exam. Please make sure that you have watched all the videos till part 5 before going ahead with part 6. Let us now look at that part. Let us now see how did the wave theory of light explained the observations or the experimental observations of photoelectric effect. Or what did wave theory of light interpret about the photoelectric effect? How did wave theory explain photoelectric effect? So let us look at the explanation given by wave theory. So wave theory, according to wave theory, what is happening? Radiation is falling on a metal plate. That means a wave is falling on a metal plate. What is that wave? That is electromagnetic wave, which is because of electric and perpendicular electric and magnetic fields which are propagating, right? So it will answer photoelectric effect in that concept. So according to wave theory, when we increase the intensity of the wave, what happens? The electric field and the magnetic field associated with the wave also increases. Now when the electric field and magnetic field increases, the energy also increases. Because we know that the energy stored in an electric field, magnetic field, everything depends upon the magnitude of the field. So now if electric field is increasing, magnetic field is also increasing, then greater energy should be absorbed by the electron. So that means energy absorbed by the electron or the energy of the electron should depend on intensity. But till now, the experimental behavior told that maximum kinetic energy depended on frequency and not intensity. But wave theory told that maximum kinetic energy of photoelectron should depend on intensity. By increasing the intensity, we can increase the electric and magnetic field. If electric and magnetic field increase, that means more energy should be absorbed by the photoelectrons. So the first thing which was explained by wave theory was not in accordance with what was experimentally observed. Okay. The wave theory did not talk anything about the threshold frequency. According to wave theory, intensity of the wave was the hero. If you increase the intensity enough, you can overcome the work function. According to the wave theory of light, frequency doesn't have much role to play in photoelectric effect. They told that, okay, this is correct that every metal will have a different work function. So if you want electron to be emitted from that metal, you will have to supply some energy. So they told that if you increase the intensity of the light to a very high extent, that great intensity will be able to provide the amount of energy that is required to overcome the work function. So there was no concept of threshold frequency at all. But experimentally it was found that frequency had an important role to play. Frequency was the one which decided when photoelectric emission will start, and it was not intensity. Intensity only decided how to increase or decrease the amount of current. But when will that current flow start? That was decided by frequency. So even at the second point, it disregarded the experimental observation. According to wave theory, photoelectric emission was not an instantaneous process. So this was again something which was against the experimental observation. But why did they say that it is not instantaneous? Because the reason behind this was that as per wave theory, what was happening? When light is falling on a metal surface, the energy of the wave is getting distributed over all the electrons which are present on the metal surface. Right? Let us suppose there are many electrons which are present on the surface of the metal. So it is getting distributed between all the metals. So now between all the electrons. Now, in order that an electron escapes from the metal surface, this electron should be able to absorb enough energy that it can overcome the work function. But since whatever energy is coming, that is getting distributed to each of them, so the time taken by each electron to absorb that much of energy is more, right? So therefore, it is like taking a long time for an electron to overcome the work function and then escape out of the metal. Whereas if we take an example, if you think of an example like this, let us suppose if you are putting water on your plants. You have 4 plants. The electrons are your plants now. If you know that for this plant to grow, it needs, I'm just taking some random example, for this plant to grow, it needs 1 liter of water. What do? You give some 4 liters of water like this. Now what happens? That 4 liter, it is not necessary that at one go, the first plant will take 1 liter of water and the second plant will also take 1 liter of water. It is not like that. You give 1 liter of water, all the plants will keep absorbing some water and gradually the amount of water intake will increase. There is another way of doing the same thing. Let us suppose you have 4 plants. You have prepared 4 packets of water of 1 liter each. And now you throw these 4 packets to these 4 plants. Now what happens? As soon as this 1 liter of water hits this plant, instantly this plant will absorb the entire 1 liter. So that means whatever amount of energy was required by the electron can absorb it instantly when it comes to it at one go. But according to the wave theory, in wave theory there was no such concept that the amount of energy or the amount of energy which is needed for emission to take place, that can come to the electron at one go. As per wave theory, the energy will come in this form and all the electrons, that energy will get distributed between all the electrons present on the metal surface, and each of them will keep absorbing it gradually. So that will take time. So in that case, photoelectric emission cannot be an instantaneous process as per wave theory. So we see that whatever explanation was given by wave theory of light for photoelectric effect, they were all proved to be against the experimental observations. And nobody can deny the experimental observation. Those people who are supporting wave theory of light, they cannot say that wave theory is correct and experimentally whatever you have seen is incorrect. That is not true, because whatever we are seeing experimentally is something which is actually happening. So this showed that this didn't say that the wave theory was incorrect, because there were so many evidences of interference, diffraction, polarization, which only wave theory could explain. Particle theory could not explain. So nobody told that the wave theory is incorrect. But now a second thought came into people's mind that there are certain phenomena which wave theory cannot explain. Right? So the conclusion was that wave theory could not explain the experimentally observed features of photoelectric effect. So that means there has to be something. There has to be some aspect of radiation which will be able to explain the photoelectric effect as well. So there came the twist. There came a twist in the story. Earlier Newton told light is of particle nature. Later these many scientists came up, they did so many experiments and all, and then they told it is not of particle nature, it is of wave nature. Now there was a question mark on wave nature, because wave nature was not able to explain this phenomenon of photoelectric effect. So now came back the particle nature of light. But now, thank you. Please visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thank you once again.